In Notability, I'll go to our 490, 491 folder, and I'm going to extend onto the Unit 2 notes here, okay? And just to follow up from what we did yesterday, we were talking about vertex form and all of these things, and you guys seem to have a pretty good handle on that. So I'm going to come down here to example 4, and I'm going to go through this kind of quickly. If I go too quickly, please let me know. But this is like a review of yesterday. That's in vertex form. And the reason we call it vertex form is because the vertex is easy to find. It is -2 for our x value and -1 for our y value. So our vertex is at -2, -1. Now, I noticed on some of your guys' homework, you didn't graph it also. You found all this information. It seemed like you knew what you're talking about, but it's a good habit to get into drawing the graph also. So I'm going to put -2, -1, put a dot there. I know the function opens downward. So I already know that I don't have any real x-intercept. So when I do this, I should get complex answers. Because if it opens downward, it cannot hit the x-axis. So let's figure that out. To find the x-intercepts, remember we plug in a 0 for y. So I do 0 equals the opposite of x plus 2 squared minus 1. Move the 1 over, so I get 1 is equal to the opposite of x plus 2 squared. Divide by -1. And now I can see where those complex numbers are going to come from. I take the square root of both sides, so I have plus or minus the square root of -1, which is actually I. And so x comes out to be -2 plus or minus I. Complex numbers, which I expected because I know my vertex is in the third quadrant and it opens downward. So things are making sense algebraically and graphically. My y-intercept, I plug in a 0 for x. So I make x equal to 0. So that's going to be the opposite of 2 squared minus 1. So that's -4 minus 1 or -5. So as a coordinate, 0, -5 is our y-intercept.
Wait, aren't you supposed to plug in the 2 to the x?
I plugged in a 0 for the x. And then 0 plus 2 is 2. That's where that came from. Okay? And now I know that, remember, this is the vertex, okay, right there, that's the vertex. And so what I can do is I can kind of take the image of this point. I know that the axis of symmetry has to go through the vertex. So as long as I'm drawing that, I might as well say that's the line x equals -2 for our axis of symmetry. And I know that this point is 2 spots away from the axis of symmetry. So its image point must be 2 spots away. So that gives me, just a little bit more accuracy in my graph there. Domain will be all real numbers, so from -infinity to infinity. Range is from -infinity to -1, inclusive of -1. All right, so that was kind of a recap of last class. You guys good with that? You have any questions? We're okay? All right, well, let me then just move on to now writing equations. See, in our last problems, we were given the equations, we had to graph them, but now it's going to give us some information and we have to write our own equation. So we want to write it in standard form. When it says to write in standard form, it typically, not always, but it oftentimes is easiest to write it in a different form and then convert it into standard form. So here's what I mean by that. In this first problem, we know the vertex is at negative 5, 2. So I already know in vertex form that that equation would be y equals some a. I don't know what a is, but I know my vertex is at 5, 2, so it's going to be x plus 5 squared plus 2. So just by knowing the vertex, I already have a huge chunk of our equation. But I have to figure out what a is going to be. That's where this other point comes in. Because I have three variables here, y, a, and x. So if I can plug in that negative 3 for x and that negative 6 for y, it means my only variable left is a, and I'd have my equation. So let's do that. I have negative 6 for y equals a times negative 3 for x plus 5 squared plus 2. And we can solve this for a. So I'll move the 2 over. I have negative 8 equals 4a. And a comes out to be negative 2. And so my answer is y equals negative 2 times x plus 5 squared plus 2. I said answer, I probably should say equation. That is the equation in vertex form. But it does ask for it in standard form. So now I need to expand that. So I'll FOIL out that x plus 5 squared. So I have y equals negative 2 times the quantity x squared plus 10x plus 25. I expanded that x plus 5 squared. And then plus 2 on the end. I will distribute the negative 2. So y equals negative 2x squared minus 20x minus 50 plus 2. And then just combine our like terms. So our final answer is y equals negative 2x squared minus 20x minus 48. All right, so a lot to that problem. So, just to go back over that, we took the vertex and wrote vertex form. That was our first step, but we did not know the a value. So then we took our extra point and plugged it in for x and y like this so that we could solve for a. And once we had a, we then just rewrote our equation with our a value. That was in vertex form. We then had to FOIL everything out and combine like terms to put it into standard form. All right, let's try the next one, which is, it's similar in the sense that it's quadratics, but it's different because it just gives us different information. So we know that it passes through negative 5, 0 and 3, 0. And 0, negative 30. So I'm just going to draw a quick sketch down here. just because it helps me visualize negative 5, 0 and 3, 0 and 0, negative 30 would be way down here. Now be careful, it does not say that 0, negative 30 is the vertex. In fact, it's not, and I'll tell you why in just a second, how we can be positive it's not. But I can determine from this that it opens upward. Okay, you can't make a parabola opening downward and hit those 3 points. It's impossible. So I know it opens upward. So there are a few ways that we can do this problem. So I'm going to talk about it from a few different angles. One way is there is a seldom used formula that uses the roots. We know that our roots are these. Okay, remember those are the x-intercepts. So at negative 5 and 3. So we could write this as y equals a times x plus 5. Okay, because that root is negative 5, times x minus 3, because that root is 3. Once again, we don't know our a value, though. But we have this point where if we plugged 0 in for x and negative 30 in for y, we could then find a. So I'm going to do that. Negative 30 is our y. We have a times 0 plus 5 times 0 minus 3. All right, so that gives us negative 30 is equal to negative 15a, and a comes out to be 2. And I'm glad a was positive because remember, it opens upward. So to answer this first part, I mean, one way to write this equation is y equals a, oh, not a, we know that a is 2, sorry, 2 times x plus 5 times x minus 3. That would be in factored form. Now I know that it opens upward. I told you guys before, though, that 0, negative 30, like this thing is not the vertex. Here's how I know. If these guys are our roots, the vertex has to be right in the middle of here and here. So this is at negative 5, and this is at positive 3. So the number right in between negative 5 and positive 3 is negative 1. Okay, you can always get that by adding them together and divide by 2. Negative 5 plus 3 is negative 2. Divided by 2 is negative 1. So that means that my axis of symmetry is negative 1. So my graph actually looks like this. Because when it asks me, like, when is the function decreasing, I need to know that x value of the vertex because that's when it changes from decreasing to increasing. So the interval where this function is decreasing, mainly this side of it, is from negative infinity to negative 1. And now to find the range of the function, well, I have to know what that y value is. Well, to find that y value, I want to know the y value when x is negative 1. Well, I could plug a negative 1 into that equation. So I get y equals 2 times negative 1 plus 5 times negative 1 minus 3. So I get y equals 2 times 4 times negative 4, which is negative 32. Which means my range is from negative 32 to infinity. All right, any questions yet? All right, I'm going to do one more problem. It's very similar to our first one. It gives us the graph, and it tells us that we want to write the quadratic in vertex form. Well, I can see here, notice the scale. If this is 10, each of these tick marks is 2. That's 2, 4, 6, 8. So the vertex is at negative 2, 8. So I have y equals a times x plus 2 squared plus 8. And I have to solve this for a. So I can plug in either point. 0, 0 is always a nice one to work with. So I get 0 equals 4a plus 8, because I plugged in a 0 for the x there. And so a comes out to be negative 2. And so our equation is y equals negative 2 times x plus 2 squared plus 8.
Wait, when we plug in, we gotta use whatever touches the y-axis, right?
Really, you can use
Whatever
any point that you want. It doesn't have to be that point. It could be any point on the graph. So
okay.
if it told us like what that coordinate was down here, you could use that point. It could be any point to plug in for x and y.
Okay.
Yep. Part B says find f of x minus 4. Remember our transformations, that just means it's going to move it to the right 4. Well, think about what changes. If I take that graph and slide it over 1, 2, 3, 4. Whoops. Yeah, I did that right. 1, 2. Sorry, I forgot my scale is 2. 1, 2, 3, 4. The only thing that changes is the x value of my vertex. So my new equation then is going to be y equals, still negative 2 is our coefficient, but now it's going to be x minus 2 plus 8 because our new vertex is at positive 2, 8.
Is it still squared?
Oh, yes, it should be squared. Thank you. X minus 2 squared. Thank you.
Are you supposed to put it in vertex form or standard form?
It says vertex form for this part, so I left that in vertex form. Oh, this does say in standard form. Thank you. I missed that part of it. So we should do that. That just means that we're going to have to FOIL it out and combine our like terms. So let's take this guy. And we're going to FOIL it out. So I'll do the x minus 2 times x minus 2, which will be x squared minus 4x plus 4. and then plus 8 on the end. Distribute the negative 2. So I have minus 2x squared plus 8x minus 8 and plus 8. And then combine our like terms, the 8s are going to cancel, right? So I have minus 2x squared plus 8x. So there it is in standard form. And that is showing that graph. All right, thank you for pointing that out. I missed that standard form. Any other questions? That was great. Any other questions before I move on?